All right, day 6, unions. So first off, it says shade green or red. So shade green or red. So, whoops. Here's green. Here's red. Let's try that again. Now, it says, are these independent? Yes. Okay. A green does not affect a red. Red does not affect purple. Are they mutually exclusive? Yes. There is no overlap. So what's probably a red? Well, first off, it's always good to find out how many there are. There's 10 total. There's 5 red, 2 green, and 3 purple. So what's probably of a red? Well, there's 2 red out of 10 total. Purple, 5 red, sorry, my bad, 5 purple out of 10 total. Oops, I think I'm missing one. Yep, gotta go up a little bit. Sorry about that. Green, there's 2 green. And I just messed everything up because I was sorry about this. Let's try this again. There's 2 green. There are 5 red. There are 3 purple. Now, blue, there's no blue at all. So that's 0 out of 10. Now, what about G or R? Green or red? We'll just add them. So 2 plus 5 is 7 out of 10. What's probably either a purple or a red? Well, purple is 3, red is 5, plus 3 is 8 out of 10. Now, what's probably either green or red or purple? That's a 10 out of 10. You're guaranteed of getting one of those colors. All right. Now, it says shade A and B. A and B is right here. Now, what are they? It says up here, a single-sided die is ruled. Okay? Which means the sample says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Event A is the factors of 6, so numbers that make 6 through multiplication. So 1, 2, 3, and 6. Event B is evens, 2, 4, 6, 8, 10, 12. Now it says write any numbers that aren't in either one. Well, that would be the number 5, 7, 9, and 11. None of those numbers are factors of 6, and none of them are even. Now, how many numbers are there? Okay, there's 12 numbers total, right? Obviously 1 through 12. Now, the probability of A, how many are in A? In the circle of A, there's 4. There's 4 numbers, 1, 2, 3, and 6 out of 12. Probability B, 6 out of 12. Half the numbers are even. Makes sense? What about A and B? Those are the 2 numbers in the middle. A or B. Now here, you gotta be careful. If you add the 6 and the 4, you get 10. But the problem is, you'd be counting these numbers twice. Okay? So there's only 8 numbers out of 12. And, 1, 2, 3, 4, 5, 6, 7, 8. Now, how many are not A and not B? Those are the outside numbers, 1, 5, 7, 9, and that's 4 out of 12. All right. Determine probability. First off, how many marbles do I have? 13. Always good to know. 6 pink, 3 yellow, 4 green. Now, for OR problems, if the sets are mutually exclusive, no overlap, we can just add the probabilities. So, pink is 6 out of 13. Yellow is 3 out of 13. Since they're mutually exclusive, we can just add them and say it's a 9 out of 13 chance to get one or the other. Yellow, again, is 3 out of 13. Green is 4 out of 13. If we add them, we get 7 out of 13. And then green is 6 out of 13, plus 4 for pink. That gives us a 10 out of 13 chance of getting either green or pink. All right, a deck of cards. How many jacks are in there? There's 4, and there's 52 cards total. How many red cards are there? There's 26, and there's 52 total. How many cards are jack and red? Well, there's 4 jacks, 2 black, 2 red, so that's 2 out of 52. Now, the tricky one is that how many are jack or red? Well, this is not mutually exclusive because there's overlap, because there's 2 red jacks. So we can't just add both of them together and get 30. We have to subtract out the intersection. So it's 26 out of 52 plus 4 out of 52 minus 2 out of 52. And that gives us 28 out of 52. Okay? Now face cards. How many face cards are there? 3 of each suit times 4 is 12. How many hearts are there? Well, only 13. But remember, there are 3 red hearts. And we cannot, let's be a 52, my bad. We cannot count them twice. So we have to subtract it out. And that gives us 22 out of 52. Here's a nice drawing to use. Okay? So, black card or a red king? Well, there's 26 of these, and there's 2 of these. Not mutually exclusive, there's no overlap, so that's simply add. If the board will decide to work nicely. So that'd be 28 out of 52. Face cards. We talked about there being 12 of them. Spade, there's 13. But for this one, there are 3 spade face cards. So we have to add and subtract. So that's 25 minus 3 is 22 out of 52. An ace or a 7? Well, you can't be both. So that's just 4 of these, 8 out of 30. Again, I wouldn't do the 32. 52. This time I even said it. D, a spade. Well, there's 13 of those. Black card, there's 26 of those. Well, technically there is an overlap. There are 13 black spades, so it's this. So it's just 13 out of 52. A 2. How many 2s are there? 4. How many black aces are there? 2. They do not overlap, so it's just 6 out of 52. You just simply add that. Red card. There's 26 red cards. There's 4 queens, but there are 2 red queens. So we have to do this little magic here, and that's 28 out of 52. a spade, or a heart. They do not overlap, so you simply add 26 out of 52. Okay, last but not least on this one, a queen. There's 4 of them. A black face card. Well, that's 6. 3 in each suit. But there are 2 black queens. So we add and subtract. 6 plus 4 is 10. Minus 2 is 8 out of 52. And the last one for this section. It says 139 young adults were surveyed. Well, that's our total right there. On East versus West Coast. Okay? So you can put top or the side. Doesn't matter. I'm just going to put East here and West here. Doesn't matter. And then they're asked their preference. Rap or punk. Again, you can switch the P and the R, the E and the W, move rap and punk to the side, E and W on the top. It does not make a difference. The intersections will be the same. Now it says 70 of the people were from the East Coast. So that's the East row. It says 98 people liked rap. That's the rap column total. 42 of the people from the West Coast liked rap. Okay? And now we just work backwards and figure out the numbers. If we subtract 42 from 98, we get 56. Going across, we do 70 minus 56, we get 14. If we do 139 minus 98, we get 41. 41 minus 14 is 27. And you can do 42 minus 27, 42 plus 27, or 139 minus 70. And all the numbers match up. Now, what's the probability of an East Coast person? Well, you find East Coast, go all the way over to the total, 70. That's 139. East Coast or punk? Well, East Coast, there's 70. Punk, there's 41. But remember, that 14 is included in both numbers. So you have to do 70 plus 41 minus 14. And that's 97 people out of 139. What about East Coast and punk? Well, that's just the overlap. So East Coast, punk, there's your 14 right there that we just used. What about just straight up punk? Well, there's 41 people who said punk out of the 139. Now, remember the special line here. This says we're going to look at the West Coast first. West Coast total. So West Coast total is 69. That's my denominator, remember? Now, on that row for West Coast, how many people picked rap? 42. Okay, West Coast or rap. This is another one of those that overlap. So West Coast is 69. Rap is 98. Well, what's the overlap of West Coast and rap? Okay, it's 42. So we have to add these and subtract that, because that 42, remember, is included in both of them. So we have to do 69 plus 98, and then subtract the 42. And that gives us 125 out of 139. And the last two, rap or East Coast. Well, how many rap are there? There's 98. East Coast is 70. Now, what's the overlap of rap and East Coast? It's 56. So we add and subtract. And that gives me 112, again, out of 139. And then last one, what's the intersection of RAP and East Coast? Well, RAP and East Coast is 56 out of the total of 139. And that's it.